Okay, so ethers are oxygen sandwiched between two carbons. And so this is what an ether looks like. It would help if you could see it. I can see it. I don't know why you can't. Better. Okay. So oxygens, an ether is an oxygen sandwich between two carbons. And a lot of times students will say, well, this is an ether too. And I say, oh, it has this whole group. This is an ether. That is not an ether. It's not an oxygen sandwiched between two carbons. It's an oxygen with one carbon on one side and a carbonyl on the other. So that makes it completely different. So this is actually, what functional group is that? Yeah, close. They're ketone? Ester. Yes, and we'll go over this in the lab 13. Yes, benzoate is an ester too. So, yeah, there's a lot to keep track of, but we're going to get it all straightened out. So, oxygen sandwiched between two carbons, that's an ether. And there are two ways to name ethers. There's the IUPAC way and the common name. And I think for ethers, it's easier to name the common name, but we need to learn both. So, with IUPAC, it's the number where the ether is, followed by alkoxy plus alkane. So instead of it being a suffix like before with alcohols and thiols, it's a prefix for IUPAC. So that's a difference, and that can sometimes make ethers more challenging to name with IUPAC. So always with IUPAC, you find the longest continuous chain of carbons. So in this example, the longest continuous chain of carbons is 1, 2, 3. So that would be called propane. Yes. And you number that way. Now, if you cover up the oxygen, this would be called a methyl group. But because the oxygen is there, it's no longer methyl. You take off the YL and you add OXY. So it's methoxy. So the full IUPAC name is 1-methoxy propane. And you might say, why does she put 1 there? If you're finding yourself asking, do I need a number here? Try to find another version of this ether that can be made. So you could have 2-methoxypropane, right? So you could have the methoxy group on the second carbon, and that would be called 2-methoxypropane. So if you don't specify 1 or 2, then it's unclear. If you imagine yourself calling a chemical supply company and saying, I'd like some methoxypropane. Okay, which one do you want? So 1 or 2.
What makes the difference in it?
What's that?
What makes the difference in whether it's on 1 or 2?
Well, it's named differently. The structure is different. The properties would be different. So, but I say that so that you can see why the number 1 is necessary. Because there exists another version of that, 2-methoxypropane. So 2-methoxypropane would look like this.
So do these have isomers?
Yep.
As well? Because that's what that would be, right?
Exactly. But I point out that 2-methoxypropane exists so that you know one needs to be put in front of the methoxypropane.
So the only way it wouldn't be would be if it's a ethane.
Yes. So if it was methoxyethane. Yeah. So methoxyethane, you wouldn't have to put the number. But, you know, I don't want you to get so caught up in, you know, if I leave the number off or, you know, like if you said 1-methoxyethane, I would give you full credit. Because there comes a point when you're just splitting hairs and, you know, the overall goal is that we want you to know how to name these functional groups, but if you can't distinguish, you know, like, it's very unlikely that we would ask you something like that. But if you ever come across it and you say, why doesn't it have a number in front of it? That's because it's always going to be 1. So common, I think, for ethers, like I mentioned before, is easier. With common nomenclature for ethers, you cover up the oxygen and you name to the left and the right. So an alkyl group. So this, what alkyl group is that? Propyl. And over here is methyl. You put them in alphabetical order. Which goes first? Methyl. So it's methyl, propyl, ether, and that's all you do for common. With common nomenclature for ethers, you're going to be kind of limited just based on the alkyl groups that you know. You'll always be able to name ethers with IUPAC, but you might not always be able to name them with common nomenclature. That makes sense? That applies to a lot of the nomenclature. IUPAC, you will always be able to name structures with IUPAC, but then common, it depends on how complicated it is, because a lot of it relies on your alkyl group knowledge. Now, if we had 2 alkyl groups that were exactly the same, then the common name would be dialkyl ether. So if we have this ether, for instance, I'm going to put this as methoxyethane. This goes up here. But this ether that I just drew, CH3, CH2, CH2, CH3. If you were to name that using common nomenclature, what alkyl groups do you have? Ethyl, ethyl. So you're not going to say ethyl, ethyl, ether. You're going to say diethyl ether.
Would there ever be more on top attached to that you would have to go alphabetical?
With ethers, we're just going to have 2 groups because oxygen only has the 2 bonds. So diethyl ether is an example of a symmetrical ether. Do you see how it's the same on both sides? You can split it in half and it's exactly the same. So same on both sides. So an unsymmetrical ether would be one that is not the same on both sides. So like the example that we did up here, 1-methoxypropane, it's not the same on both sides. Methylpropyl ether, unsymmetrical. But diethyl ether, since it's the same on both sides of the oxygen, it's symmetrical. So I want you to go through and name these ethers. I'm going to help you out on this middle one. Now, it just has a line for IUPAC, so it can't be named with common. So IUPAC, what's the underline? Always you're thinking about with IUPAC. Parent chain, so the longest continuous chain of carbons. So which way would we number it? Left to right. So 1, 2, 3, 4, 5, 6, 7. So that parent name would be heptane. Excellent. Now, what is that thing coming off heptane? Yes, phenoxy. Excellent. So it would be phenol. This looks like phenol, but it has this oxygen. So you get rid of this YL and you add oxy. So it's phenoxy, 3-phenoxyheptane. Excellent. 3-phenoxyheptane. So I want you to practice these ethers. So IUPAC common, IUPAC common. Now remember with common, you're just covering up the oxygen and naming the alkyl groups on either side. The common cover up the oxygen have methyl, so it would be dimethyl. Okay, so this first one is it symmetrical or unsymmetrical? Symmetrical. So IUPAC, just choose one side as your parent. It's going to be 1 carbon. I'll choose this, so that's methane. And then what's my ether going to be called? Methoxy. So methoxy, methane. Do I need a number? No. Not until common.
So could you do, well, I guess you wouldn't need to do one line.
Don't need a number because there's only 1 carbon it can be attached to. Okay, common is going to be cover up the oxygen, methyl, methyl, so it's dimethyl ether. So the symmetrical ether that I gave, this is common, diethyl ether. The IUPAC name, much like methoxymethane, is going to be, instead of methoxymethane, it would be ethoxyethane. Okay, this, you want to do IUPAC first or common first? IUPAC, the longest continuous chain of carbon, what's that? 3, good. So propane. And then off the second carbon, what do I have coming off? 2 methoxy propane. And then for common, we're going to cover up your oxygen and Look at your alkyl groups. So methyl, isopropyl. Which comes first? Isopropyl, isopropyl, methyl ether. I have confidence in you guys. You're going to get this. You will. It just takes a little head banging. So I wish I could bang my head on the wall for you. I could, but it wouldn't too much. Thank you for pointing. I mean, yeah, I need to. I couldn't. Why isn't it working?
It'd make my head color.
Yeah, I know. Okay, on the next page, I have alcohols, ethers, diols, all mixed together. I want you to practice this. So I'm going to skip this. We're going to come back to it. When you have a chance, try and fill this out for practice. We might get a chance at the end of this session. I wanted to get into solubility of alcohols and reactions of alcohols for our lab tonight, because this is what we'll be doing. What does the structure of methanol look like? Excellent. 1 carbon, CH3, OH. So this is, what, does anybody know what happens when you drink methanol? What's that? What burns your eyes. So you can go blind if you drink methanol.
Oh.
So that's wood alcohol. You don't want to drink wood alcohol. Stick to the ethanol. But then other things might happen too. But methanol is known to cause blindness. So methanol compared to 1-heptanol. What's 1-heptanol look like? 7 carbons. 2, 4, 6, 7, and then an OH at the end. So when you're looking at solubility, remember, soluble means it mixes with water. Insoluble does not mix with water. So this kind of goes back to that like dissolves like. Looking at these alcohols, methanol and 1-heptanol, which one do you think is going to be soluble or mixed with water? Which one's more like water? Methanol, absolutely. So small alcohols are soluble in water. And small alcohols are 4 carbons or less. So larger alcohols, what do you think about them? Are they going to be soluble or insoluble? Insoluble. So ethers and alcohols are more soluble than their corresponding hydrocarbons. What does that mean? What am I trying to say? So remember, ethers look like this. Alcohols look like this. And hydrocarbons, it sounds like they're like water because of the hydro, but remember, hydrocarbons are just made up of carbons and hydrogens. They don't have anything that's like water. So a hydrocarbon, depending on which one you're speaking of, so this is 1, 2, 3, 4, 5, hexane. There's nothing in this hexane that water is similar to. So the OH or the oxygen. So ethers and alcohols kind of have that similar group so that if they're small, they will be soluble in water. So they're more soluble than the corresponding hydrocarbons. So if you were to look at butanol compared to butane, like one butanol, it's going to be a lot more soluble than butane in water.
That's a good question real quick. It's
Sure.
not off subject, but it's about the quiz. When we're looking at the flashcards and the quiz, are they going to correspond to what's looking on the flashcard or what we're seeing here? Because it's more complicated looking at these than just breaking them down what you have on the flashcards.
What, and so when you say on the flashcards, you mean like the orange flashcards with the
Or it's just the simple groups.
names? Yeah, so there will be those, and then there will be the note packet too. So that will be all.
On the quiz?
Brace yourself.
Can you? When you write the OH, can you put them on top? Or they
Yes. You can put them on the top, on the bottom, to the left, anyway. Because, if you think about these molecules, when you build them, you can have them sitting on your bench top in a certain way. You can rotate them, you can pick them up, flip them over. That's just how they are, so yes. Okay, on the next page, I have reactions of alcohol. So write the reactions and or products for the oxidation of alcohols. So we talked about oxidation and reduction in Unit 2. So oil rig, we have the line says GER. In organic chemistry, oxidation can be defined two ways. The loss of hydrogen or the gain of oxygen. We are going to look at the first definition to begin with, and then we'll see the second definition a little later on. So 2-butanol, how many carbons does it have? 4. On the second carbon, what do I have? OH, CH3, CH, CH2, CH3. How would you classify this alcohol?
That's a 4 carbon, so it's a small.
Small alcohol, so you're talking about it in terms of solubility. When I was asking about classifying like primary, secondary, or tertiary.
Secondary.
Secondary. Okay, so remember to classify alcohols. You look at the carbon bearing the OH. You see how many other carbons it's bonded to classify it as primary, secondary, or tertiary. That's the easy part. Pretty soon this will all seem easy. It just takes a little bit. It does. So when you see an alcohol with an arrow and this oxygen in brackets, that means an oxidation reaction. And what you're going to be doing is removing a hydrogen on the OH and a hydrogen on the carbon bearing the OH. So you'll take this oxygen off, or not oxygen, this hydrogen off, the oxygen, and this hydrogen off the carbon bearing the OH. And then what's going to happen is a double bond will form. So that's the only place that you see anything happen in this molecule. You're kind of focusing on the alcohol. So you copy everything else down in the molecule like it was before.
Would that be a ketone then?
It's a ketone. Excellent. like Natalie said, secondary alcohols oxidize to form a ketone. All right. Ethanol. What's the structure of ethanol? 2 carbons with an OH. So, primary, secondary, or tertiary? Primary. So I'm going to get rid of the hydrogens, 1 on the oxygen, 1 on the carbon bearing the oxygen. So what I end up with I've written this product 2 different ways. Either one I would accept. What functional group is this? Aldehyde. So this is an aldehyde. So the breathalyzer test, the way it works is by seeing how much alcohol in your breath reacts with the reagent that oxidizes ethanol. So it's measuring the extent to how much of that reagent it uses up. If it uses a lot, then you have a lot of ethanol in your breath. So your blood alcohol content based on that would be high. It's based on a color change. So, and you'll see tonight in lab, the oxidations that we carry out, you see a color change. And so, but this acetaldehyde, or ethanol is another name for it. This is the one that makes you feel really crummy, a hangover. So, but primary alcohols oxidize to aldehydes. Now we're going to look at another alcohol, 2-methyl-2-propanol. So start with your parent, 2-propanol. So 3 carbons. And then on the second carbon, you have an OH. And on the second carbon, you also have a methyl group. How would you classify this alcohol? Tertiary. I heard it. Good. I'm going to write out a product. It's not going to be correct, but I want to show you something. This is what a lot of students do with tertiary alcohols. Done. Walk away. What is wrong with my structure? Too many bonds to carbon. So this is when that alarm should be going off. I have 5 bonds to carbon. The reason this happened is because you look on the carbon bearing the OH, I don't have any hydrogens to remove there. So since I don't have any hydrogens to remove there, a reaction cannot take place. So this does not happen. What actually happens? No reaction. You can't oxidize tertiary alcohols. So in summary, and a lot of students write this on their exam when they get it. It's kind of your little cheat sheet. This has been helpful in the past to students. Primary alcohol oxidizes to what functional group? Ketone. Is that right? Thank you. Primary alcohols oxidize to a ketone. secondary alcohols, I said it wrong again. Primary alcohols oxidize to an aldehyde. Secondary alcohols oxidize to a ketone. Tertiary alcohols, no reaction. So if you look at those reactions involving the tertiary alcohols, no reaction takes place. What happens is it's just the reactant. So it has not been converted to anything. So on the next page, I have some alcohol oxidation reactions. And I want you to practice now. So focus on the carbon bearing the OH. If it helps you, kind of zoom in on that. So this is where the reaction is going to take place. If there's not a hydrogen on the carbon bearing the OH, no reaction can occur.
So when it's a cycle, does it break then? Or?
See if there are hydrogens there. So when you're dealing with geometric structures, these are typically the most challenging for students. And it's likely you will see one on the exam. Don't guess whether a hydrogen is there. Draw it out. So look at that carbon that bears the OH. Say, count up the bonds. How many bonds can carbon have?
4.
4. So this is 1, 2, 3, 4. Can it have a hydrogen there? No hydrogen. So if there's no hydrogen, what happens? No reaction. So you go on to this one, and again, geometric structures cause a lot of grief for students, but the first thing you do is look at that carbon bearing the OH, draw a hydrogen there if it's there, so you know. So how many bonds do I have explicitly shown here? 3. 1, 2, 3. So that means I have 1 hydrogen, right? The other thing that can be helpful with these geometric structures is to classify it. So say primary, secondary, or tertiary. What would this one be? So this is secondary. What functional group should I expect? Ketone. Good. So I get rid of hydrogen here, make a double bond, and I end up with that guy. So I went from cyclobutanol to cyclobutanone. And I'm not asking you to name these, but the more you hear these and see these names, the easier it will be for you to learn that. All right, what about this second alcohol? So primary, secondary, or tertiary? Primary. So it should oxidize to make a aldehyde. Let's see. Get rid of one of those. So CH3, CH2. See, a lot of times you'll see the carbonyl and aldehydes written vertically. So it's kind of the convention. But if you write yours to the left or the right, that's fine too. Okay, so this is 1-propanol, and it oxidizes. What's the name? So Al for aldehyde, so propanal. Since aldehydes are always at the end of molecules, I don't need to put a number, so it's propanal. Okay, this would be phenol. Okay. Then this last one, primary, secondary, or tertiary? Tertiary, good. So since it's tertiary, because you look at this carbon, it's bonded to 1, 2, 3 carbons, and does it have any hydrogens? Doesn't it have any hydrogens there? Right, so anytime you find that you are dealing with a tertiary alcohol, no reaction. So a lot of times I get students who are kind of no reaction crazy. Once they find out about the no reaction, they just want to put no reaction, no reaction, no reaction, and be done with it. And maybe 1 out of 5 of those would be a no reaction, but just be careful, you know, when you're doing that. You could, oh, this, I know this one's no reaction. So, all right, let's go back to page 8 and work on this nomenclature here. Oh, it's fun. You guys can name these. I know you can do it.
Oh, it's like the gift that keeps giving.
So I know a lot of you are struggling with this, just kind of getting used to the nomenclature. So that is perfectly normal. It will get easier. This first one, the parent is phenol. So remember Phenol. This is from your orange flashcards. Like toluene, the OH gets the number 1. So it's the most important. So 1, 2, 3, 4, 5, 3, 5 dichlorophenol.
And it's okay if you number it the way I remember.
Right, you would have still gotten 3, 5. And then no common name for that one. This next molecule, it's an ether. Before I mark it up, I'm going to do common. So I'm going to cover up my oxygen. And I end up with methyl on one side, T-butyl. Right, so T-butyl, methyl, and I think I missed that on yours. T-butyl, Abby, T-butyl, methyl, ether. This is, you know, when you go to the gas station and you see MTBE added, this is methyl terbutyl ether. That's what they add. So it's an anti-knocking agent. So when you see that now, oh. They alphabetize differently than we do, but since T is a prefix, we alphabetize B first. B goes before M. Okay, now for IUPAC, what's the longest continuous chain of carbons? Propane. Propane here. So look at what's coming off. So you might be thinking common, oh, that's methyl, that's another methyl. You have methyl on this side, and you have methoxy on this side. So you're going to list them alphabetically. Methoxy comes before methyl. So it's going to be 2-methoxy, 2-methyl propane. Questions on that one?
How many points do you take off if you do it alphabetically?
Oh, out of a 3-point question, I'd probably take off a half a point for that. So not a huge amount. That is the nice thing about, you know, these questions. I'm able to give you partial credit. Okay, this next one, what functional group is it? Alcohol. So this is, you add OL for IUPAC. For common, you do alcohol. So I'm going to do common first. Cover up the OH. What alkyl group is that? Isobutyl. Isobutyl alcohol. So it's not what? It's not isopropyl because it has 4 carbons. It's similar to isopropyl. If it was attached to that center carbon, then it would be isopropyl. All right, for IUPAC, it's propane. but then you do what to the E, you change the ending, you add OL, so OL, and I have to put what number that alcohol is at. So it's 1-propanol. What else is coming off that chain of 3? 2-methyl, 1-propanol. So I know there's a lot of resistance to this nomenclature at first, and the more you resist it and fight it, the harder it's going to become. You kind of have to relax to take it in, and then keep practicing.
I just wish there wasn't 2 different ways to do it, because
I
that's, I
know.
get screwed up. But
And the reason we teach you the 2 different ways is because sometimes, you go into a doctor's office, it's not called 2-propanol, the alcohol that you use. It's isopropyl alcohol. So you kind of see a mix all around us. And so we want to inform you the best we can. So yeah, it is a challenge to get used to, but like I said, that student who didn't study very much at all, but he studied that table with all the systems of nomenclature, he did quite well, so if you can keep going back to that and kind of keeping that in mind and not fighting it, just kind of saying, okay, what's, having a system. I know in the beginning it's challenging, but also we have to learn it. But state of Kansas requires us to teach you this, so, gotta dig in and learn it.
What was the abbreviation for the T-butyl thing you said? Yes.
NTBE, and you can't see this. All right, so we'll do these last 2, and we'll go to lab. Common for this one, hopefully common for ethers is maybe getting a little bit easier. See alkyl, alkyl. So that's butyl, dibutyl ether. And then IUPAC, since it's a symmetrical ether, just circle 1. That's your parent, and the other one will be your substituent. So that's a chain of 4. That's butane. It's going to be, this would be butyl, but it has an oxygen. So now you're going to change the ending to butoxy. 1-butoxy butane.
that's what I did, but I'm like, it just looks weird.
Mm-hmm. Right, it's a foreign language, so everything looks and sounds and feels very
Do we
strange.
need the number?
Yes, because you could have 2-butoxybutane.
It's good way to intimidate people when you go to those restaurants where they have crayons in
Yeah,
them.
right,
So whip it out
Just
and
start drawing all that out.
right, yeah. All right, this last one, what functional group is it? Alcohol, but you have 2 of them. Di-hol. So this is your chain of 4, so it's butane, di-hol. But these alcohols could be off. They could be 1,1-butanediol, 1,2-butanediol, 1,3-butanediol, or 1,4-butanediol. You have to specify the numbers. So 1,4-butanediol. So